So last time we learned like what is blockchain. So just to I'll start with a recap. So what is blockchain is there is a block. We store transactions. A sends some funds to B and amount like this something. This is a very simple blockchain. There is a list of transactions and we store all those transactions in a block and we create a list of a link of those blocks and we call it a blockchain. Okay. So that's how it was invented. Like when like the world first got to know what the term blockchain is. This is how simple it was. Just a list of transactions, nothing else. Okay. Uh, yeah. So when people saw this version, they thought that it could be improved. So what we can do right now, this blockchain has only one function. Let's consider it as a there is some code on this blockchain that can execute one function. Like it takes transfer. Okay, it takes three parameters from address to address and amount. Okay, there is only one function and only this function can be called. Nothing else can be called. That's why each transaction is just implementation, different values put into this same function. So what people thought, why not create a list of why not allow people to create any function like this, which has a predictable outcome? Because once we create a new function and just store it on the blockchain itself, so any people can call it and there will be different conditionals. Now, right now, there is only one function. Why not create another functions and allow people to call it? So that's how we started to get a programmable blockchain. So what programmable blockchain means is so along with storing just the address, the balances of the people, we also store some code. Oh, okay. So we also store some code on the blockchain that can be executed by anyone, by that can be called by anyone. So and that has some conditionals. Okay, and that's what we packet that code as a smart contract. Okay. Okay, and how does a smart contract work? So a smart contract stores some data. It has two parts. Okay, some data and some functions. Okay, so in data we can store, let's say, who created the smart contract. If there is any state we have to store, like for example, we can store balances, or it could be a table. Let's say a table of some people. Let's say Ashish and his birth date. Let's say birth date is stored. Like my birth date is stored. Chetan is there. His birth date is stored. Something like this. We can store. There is some data here, and there are functions. A list of functions. Okay. So the function might be uh, wish happy birthday or something like this. There will be a function and maybe someone's name, and that function will call do some work. That function will check some functionality, and this entire thing is stored on the blockchain itself. Okay, and whenever someone calls this function, we call it a transaction. Okay, so whenever a function this data, because why we call it a transaction, because this data can only be changed through a transaction. Okay, so whenever we have to change some data, we have to create call one of the functions from that smart contract that will change that data. Okay, so that's how this data is changed. And in now how does a blockchain work related to this? Okay, so we divide blockchain in two parts. Okay, the first part will be a data storage, and the other will be a blockchain itself. Here we will store all the functions that got called. Okay, so from my smart contract, someone called function one. From someone else's contract, these all are transactions. This is actually a block, and there is a list of functions that were called through from any smart contract. And what they are doing is this data. They are changing this data. We are storing something called state. They call it world state. Let's say there is a smart contract and there is some data. Okay, and so there is one function. Okay, send money. Okay, and no, we have to make sure that this function is going to be executed on each node. Everyone will call that function. Everyone will execute that, and whatever the result is there, based on that results, they will update this data. This will be updated. So we have to make sure that everyone's result is same. Everyone's result must be same. So that's why they have standardized. We don't want any language to be used. That's why to write this code, we created the language Solidity. For most of the languages, for most of the blockchains, they use Solidity smart contract itself. Apart from few, let's say, if I have to take examples that are exceptions, Solana is one exception. Solana uses Rust. Rust is actually a general purpose programming language. You can use it to like develop some normal applications as well. But you can do write Solana smart contracts in Rust as well. But while developing Ethereum, we didn't want to take any risk. Let's create a new language that has we just don't put in the functionality while creating the language itself that could result in different people getting different results for running the same function. That could happen in Rust because Rust has a basic feature called random numbers. If you want to generate a random number, Rust can generate that. Solidity cannot generate because we want to make sure that whenever someone is executing the same function, the result should be same. If we generate a number randomly, the result will be different for each node. Okay, so there were some restrictions. That's why we created a new language, and we write those functions in Solidity itself. Okay, so that's how we store. We divided this blockchain. One is a blockchain itself, where the blocks are there. Inside blocks, we are storing the transactions. Transactions are nothing but some functions call from some of the contracts. Okay, so these are what we call a transaction. That is just calling one of the smart contract. It could be anything, and those transactions are just updating the world state. Functions are like a written code, and it is functions we use to update the data. Uh, we want to do some like if we are storing the data, we want to run some conditional code based on that data. So that's why we use functions. Functions are used to either there could be two functions. Let's focus on the only one. Functions we use to update the data. Okay, and whenever some function is called, the data is updated. So we call it a transaction because due to that function, the data has changed. So the world state will change. Yes, that's how we updated from Bitcoin. So Bitcoin was the simplest blockchain, just one function. Now we have an ability to write as many functions. We can write our own logic. So I'll give you an example of a smart contract so that it will you will better understand. Okay. So let's consider there are two parties, Ashish and Chetan, and we don't trust each other, but we want to transfer some fund. Let's say I want to send some gold to him, and in return he wants to send me some, let's say USD. Okay, some currency. But because we don't want to trust each other, in general, how will we do it is, uh, we'll I'll give my gold to some third party person, and he will also give his USD to this person, and he will transfer that USD to me and gold to him. That's how it might work. Or else we might like come together, or there could be various other solutions, but we could do this using a smart contract. Okay, so how would that smart contract would work? Okay, so there would be a contract. This third party will act as we'll just create a contract that says uh, uh, submit your asset, and the another one is withdraw your asset. uh, okay, uh, withdraw. Okay, so A goes and submit his assets. Okay, and while withdrawing, we just check the condition if they have submitted or not. So what will these are two functions. Now our smart contracts is comprised of functions and data. Okay, and in data, what will we store is submitted. So we'll just store the data that whether A has submitted his assets or whether B Ashish and Chetan. Let's say, so whether Ashish has submitted his assets, will let's say true or false. It will be false initially because he hasn't, and there will be Chetan. So he has whether he has submitted assets, that will be also initially false. So what this submit, if I call it, for me this will change to true. False will change to true, and when I call the withdraw, because he might not have yet submitted his asset, I cannot call the withdraw, but at least I have submitted my asset. So when he calls submit, he's also true is set, and in withdraw function, we just check if you have submitted and the other person has also submitted or not. So we just use these two functions to make the similar transfer. Okay. Actually, that functionality should also be there inside the like submit your function itself. So in Solidity, uh, kind of, but like Solidity cannot talk to the internet. Let me tell you, because the internet is random. Like it's like, let's say we have a function for what we call that. I'm not sure. Uh, Insurance. Okay, insurance. Okay, and we want to check if the rain has happened on this particular day. We will provide this much funds to the farmer, or let's say there is some condition, but Solidity do not know how to check if the rain has happened or not. That data should also exist on the blockchain itself to check. If that data is not there on data store, Solidity will not know. Solidity does not talk to the external internet, let's say, because the external internet, there are 10, like 100 different nodes that are all executing this function, and they get different data. How will we come to a conclusion of the same? We want to make sure that like every node that calculates this function should result to the same result. The execution of that function should give us the exact same result for each of the nodes. So different node might get different data from the internet, and that's why the function should just talk with the world state itself, not with the external world. Yeah, we can actually write a smart contract like that. So let's consider a smart contract where there are two functions. For you, there are two functions make payment, uh, called make payment. Okay, and there is one more called schedule call. And in data, we will store pending amount. Okay, so whenever you call this schedule call function, you have to, because to call a next session, you have to schedule a call, right? So inside this function, we'll check the condition if the pending amount is greater than zero or not. If it is greater than zero, you cannot schedule a new call. So you have to make payment first. So when you make the payment, let's consider this will be a payment in Ether itself, or native currency Ether. Uh, so you have to make this payment, and this payment, once the payment is complete, this sets this value to zero. So once you make this transaction, that means once you call this function, the function is changed, like the value is set to zero. Then you can schedule a call. Then you can once again, if you call this, the call will be scheduled. Uh, yeah, so schedule a call means you will just send some transaction itself to notify Chetan. You can't actually go on, like let's say Google Meet and schedule a call through Solidity. That cannot be done. That means just sending a notification, let's say, to through the smart contract to Chetan to like schedule a call. That's how it might work. Okay, so that's how it's just we are just expanding this functionality. We are making sure that instead of just one function, that is from to and amount, just transfer, that instead of that function, we can store a lot of data and we can create a lot of function that improves our functionality. And what this gives us, so what a smart contract enables us, the three most popular, or I would say the most what smart contracts enabled us to do, I'll just list them down. The first one is DeFi. The second one is DAO. Uh, and the third one is NFTs. Okay, so layer one means the native blockchain. So Ethereum is a layer one, is layer one. So no, no, no. Ethereum is layer one. For Solana also, what happens is the Cardano is also layer one. So how it works is, because I think we discussed this that Ethereum, we cannot make a lot of transactions per second. The transaction speed is very low. Yeah, so there might be a load, and also it could be very costly because Ethereum gas fees is also like these days very high. So that's why what people do is they create another blockchain and they compile this entire block as a single transaction on Ethereum network. So this there is another blockchain itself that we call a layer 2, and what this is this it's taking multiple transactions, compiling them into a single transaction so that Ethereum can indirectly complete lot of transactions, lot of like transactions per second would increase the throughput. Okay, so that's what is like layer one and layer two, because like layer ones are have to be decentralized. Like for example, for Ethereum, there are more than like 10,000 computers running the same code, saving same data, running same transactions. So it is actually like a lot of power hungry. So uh, writing a lot of transactions there is costly actually. So that's why we use layer two, where each layer has, let's say, thousand nodes, and then this makes it less decentralized as compared to Ethereum because it has less nodes, uh, and that makes it let's say a layer 2 has 100 nodes itself, so there is a higher chance of 51 or 60 of those nodes uh, not behaving properly and verifying false transactions. So that's why the security is lower, but it has the benefits of higher transactions throughput and less gas fee. That would actually become, if Ethereum increases its transaction throughput, then we don't need a layer 2. If Ethereum decreases its gas fee, why do we need a layer 2? We can just call those transactions, deploy our smart contract directly on Ethereum itself, the layer 1 itself. The so Hmm, 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 hmm. Hmm, hmm. Uh, Actually, there are some points many people call it that problem is actually insolvable. So I will tell you there is a very good term, a very popular term in blockchain called blockchain trilemma. Okay, so there are 3 points. Let's say there is a triangle. First is a decentralization, means how many nodes are running it. Okay, decentralization. The second one is security. Okay, and the third one is how scalable it is. But that means how many transactions it can run, how much data it can store, how fast it is. That's the third point. Okay, and you have to compromise one of the things for other two things. So so many people think currently at least that this problem is insolvable. We cannot achieve all the three things. We cannot create something that is very decentralized. That means thousands and thousands of people are running it currently. Means thousands and thousands are participating. It is secure as well, and it is scalable as well. There cannot be a network which completes all these three. So if there are many computers, it will be less scalable because we cannot multiply this many data. Let's say just we have to just send some funds from me to you. The thousands and thousands of computers will have to make that computation. Will have to change the data in their database wherever they are storing. That much data storage will be consumed. So if it is more decentralized, it will be less scalable.